So we're going over the homework from last night. Last night's homework, you had 4 problems that dealt with centripetal force. And so the centripetal force equation, sorry for that. Centripetal force equation, F sub C stands for centripetal force, is equal to mass times velocity squared over r. Now, if you multiply both sides by r, you get it in this format right here. FCR times mv squared. Now, if I wanted to get r by itself, I would divide both sides by centripetal force, and I would get this equation. One of them that you need to solve for one of the problems below. If I wanted mass by itself, I would have to divide both sides by v squared. So m is equal to centripetal force times radius over the velocity squared. And then if I wanted v by itself, I'd have to divide both sides by m. So doing that, all right, would just give me FCR over m is equal to v squared. To get rid of the square, I'd have to square root both sides. So that is why we have this here. So first problem, pretty straightforward. You have mass, you have radius, you have velocity. Everybody's in the unit that they need. Mass is in kilograms, radius, meters, velocity, meters per second. So centripetal force, type everybody in. You're only squaring velocity. That is an important part. Okay, so you wouldn't want to do 2 times 4 first equals and then square. Okay, 4 squared equals times 2 equals divided by 0.5. You're going to get 64. And force, the unit for force or any force is the Newton. The next problem. You're given mass, you're given radius, and this time centripetal force. So these are your variables. They want you to find the velocity, v, question mark. All right, if we take this equation, to get v by itself, divide both sides by m, that gives me v squared. To get rid of the square, you have to square root both sides. So we're going to be using this equation. F was 50 newtons, radius 25, and the mass 500. Do what's underneath the square root symbol first, and then type it in. If you got 2.5 for this one, you did not square root it. That was a pretty common mistake in my other classes. So make sure we do that, okay? Make sure you do take the square root. Here, a few people got this one off. They were off, but they showed the right work, so they would only get like a point off. Because they had the wrong number, but you also make sure you guys got to have the unit as well. So in this one, we're given mass, velocity, centripetal force. They want to know the distance from the center of a circular path, guys. So the center, when they're asking distance from the center of a circle, it's that. They want radius. They want the radius. So that is why we rearrange the equation to get our r is equal to mv squared divided by the centripetal force. So in this, okay, taking our pieces of information, plugging them in the right positions, 5 squared, 25, times 3.5 equals, and then divide by 28. You should get 3.125, or if you round up, 3.13. And the unit for that will be meters. The last one, you're given velocity, radius, centripetal force. They want to know the mass of the truck. Taking the centripetal force equation and rearranging it to solve for mass, we see that we are going to use mass is equal to the centripetal force times the radius divided by the velocity or tangential velocity squared. 18,000 times 20 equals, then divided by, I just threw it in parentheses in my calculator, 40 squared, and I come out with 225. The unit for mass has not changed since we've been using it. It is the kilogram. So that, all right, that is, all right, the review piece for the homework from yesterday. Today's assignment, all right, the circular motion problems. All right, so problem solving here. You are given a few different things. All right, you're given a bunch of equations. Frequency is 1 over the period. The unit is for frequency is the hertz. The unit for period, capital T, if you don't know what that is. Okay, period. That's what the capital T stands for. F is frequency. Velocity, tangential velocity, linear velocity, or speed. Centripetal acceleration. Centripetal force. Okay, so again, some people were losing points on this assignment because they were not labeling. They said I didn't know. Guys, these are on your paper. Frequency is hertz, period seconds, velocity meters per second, acceleration meters per second squared, force the Newton. Now, there is a second equation to solve for velocity. Taking the centripetal acceleration times the radius and then square rooting it. So it's basically just taking this equation and rearranging it. So there's one problem where you are going to use that. And then mass needs to be in kilograms, radius needs to be in meters. So there's two other little pieces of information. If you, for example, had a rope and you're holding onto the rope and on the other end of that rope is a ball. If the rope is 5, or let's say just 2 meters, and you swing that around, is the 2 meters the diameter, or is that going to be the radius? The radius, because as you swing that, as we take this thing and swing it, that 2 meters stays, all right, constant. Now, if they said this right here, right, if they asked or gave us a diameter, this diameter would be 4, right? But in these problems, we have to make sure that we are using radius. There is only one problem on here that gives you diameter. So how do you find radius from diameter? R is equal to 1/2 the diameter. So make sure you write that down. Okay. I believe there is going to be a problem where it's like, oh, they may not tell you radius or diameter, but if you have something with a certain length and you're swinging it overhead, then yes, that is going to be your radius. And the other two thingies that you would need that should help you solve the rest of the problems, all right, were from the notes from yesterday. Period, capital T. Okay, the time for one revolution, one cycle, one spin, one rotation, one lap. All right, that's why I use the word cycle, because it can mean all of those. All right, and frequency are the number of spin cycles per second. Because we want it in hertz, they need to be per second. So one of the problems is going to say you make one lap around a track in 9 seconds. What is that? Well, because you made one lap around and it said you did it in 9 seconds, that would be t. And then from there, you can use t and the radius to find the velocity. Once you have velocity, you can find acceleration. All right, there's multiple ones where you can, once you get one or two things, you can then solve for whatever else you need. How many minutes, or how many seconds are in a minute? 60. So there's going to be a problem where they're going to tell you you make 27 rotations or revolutions in 1 minute. Well, the total number of cycles would be 27, but we want seconds on bottom, not 1 minute. So it'd be like 27 over 60. We'll get to that one. First one is an example that's already worked out for you. All right, 2 and 3, they have the equations for you, so you guys should be, all right, chilling with that. So number 4, what are they asking you for? They're asking you for the centripetal force. So in each of these, they're giving you a mass, they're giving you a radius, and a velocity. They're giving you a mass, a radius, and velocity, and they're asking you to solve for centripetal force. Please make sure you're putting your decimals in the correct spots. Okay, I had people today showing the right work, but they were getting answers that were like off by a factor of 10. So that's like a difference between getting something like as 70 or 700. Kind of a big deal. All right, so please make sure that you are putting your decimals in the correct spots. 5 and 6, they're asking you to solve for the centripetal acceleration. They're giving you the speed and velocity and a radius. So that should be pretty straightforward as well. So number 8 is one of the ones where I did want to mention. We talked about yesterday 3 horses on a merry-go-round. So if you have 3 horses that are chilling, right? And I think we did this outside with the meter stick. Okay, if you have 3 horses, 1, 2, 3. 1, 2, 3. All right. And they're all attached to this same rail. All right, so as they go around, do they make the same amount of laps? So basically look at the red line. The red line would be these 3 horses as they move around the circle. Here's the first lap. Did any of the horses make more laps than the other? No. But if you notice, right, how much further the outside guy had to travel than the inside, or middle, and then the inside. So they would all have the same rotational speed, same frequency, and therefore they're going to have the same period. It says that they all complete 1 revolution. All right, so 1 revolution, 1 lap in 9 seconds. So that means for all of these, the period is 9 seconds. So you want to write that in for number 8. And so what they want you to do is calculate the tangential speed. So remember, guys, tangential speed, tangential velocity, linear speed, linear velocity. They are all referring to the same thing. All right, they're referring to the v, which is going to be 2 pi times r, and you're going to divide it by the period. So now this problem should become much easier. Okay, number 9, you're given acceleration and the radius of 4.1 meters. They want you to figure out v. So what equation has v, acceleration, and r in it? It's this equation, v squared over r. So if I multiply both sides by r, then I would have v squared is equal to the centripetal force times the radius. Remember, I got to get rid of the square. So to do that, I have to square root both sides, which gets rid of this. So this is going to be the equation that you need for number 9. All right. Someone was like, I don't know what C is in my 1 class. C is not anything right here. It is just attached to A. It could, because it stands for centripetal acceleration. Okay, number 10. What are they giving you? Well, they give you radius of 2 meters. And what else? They say this carnival ride rotates 1 time in 0.9 seconds. So is that a frequency or a period? Period. Okay, remember, period is the time it takes to just make 1 cycle, 1 lap, whatever. So you have R and you have t of 0.9 seconds. It says A, first find speed of the rider. So first thing they want you to do is find V. 2 pi r over t. Okay, so you're going to need to solve for that first. You have radius and the period. Once you get V, then you can find the acceleration by using V squared divided by R. Number 11, let's read this. Cement mixer that has a diameter of 5 meters turns with a frequency of 0.0200 hertz. What is the centripetal acceleration acting on the inside wall, on an inside wall? So they give us diameter, guys. Again, we talked about it on the front side. How do you find radius from diameter? You take half of it. So the radius, instead of it being 5, should be 2.5. So you're going to need that. How can I find the period with frequency? So t is equal to 1 divided by f. This is f, 0.02 hertz. So if I do 1 divided by 0.02, that will give me the period. Once you have that, you would then have, just like in the problem above you, you would have R, and whatever this value for period would come out would be T. And then I wrote the question marks out for you. Then I want you to find velocity. And once you have that answer, then you can solve for the centripetal acceleration. Okay, so I pretty much have you guys set up on that one. Now for 12, there's just a couple little extra steps. They give me mass. There's a typo right here. It said radius was 1 meter. It's 1.2 meters. So we want to fix that real quick. First thing it says to do, find frequency. Frequency. Well, we had an equation for it on the front side. 1 divided by the period, but we don't have that either. But we do know that frequency is the total number of cycles per second. So with that in mind, we complete 27 cycles or rotations, revolutions, in 1 minute. So how many seconds are in 1 minute? 60. So doing that, you're going to get a frequency here of 0.45 hertz. Then you can find T. Then, after you have T, because you have radius, you can find V. And then once you have V, you have enough to find the centripetal force. Mass times that V squared divided by R. All right, so let's just actually work this singular one out. So 1 divided by 0.45, this comes out to be 2.22 repeating. The unit for this is the second. Okay, so first thing we did was found frequency, then we found the period. Now you have this, you have 2 pi times r. R was 1.2 over the period that you just found. So 2 pi. So what you can type this into your calculator, guys, like this. You can just use the pi button. So 2 pi times 1.2 gives me that, and divided by 2.22. Okay, this is going to give me 3.396, so I'm going to call that one 3.4. Unit meters per second. And now centripetal force. Mass is 3.4. V is, oh, well, all right, well, 3.4 as well. We're going to have to square that because velocity is squared. And then the radius. The radius, what the hell was the radius again?
1.2 meters.
Yes, sir. Yes, sir. And then we are going to plug and chug. So 3.4 squared equals good times 3.4. All right, so that's my top line. Then on the bottom, divide by 1.2. And I get an answer here of 32.75333333. So we'll round it at, we'll cut it off at the 0.75. So 32.75. And what is the unit for any force? The Newton. Okay, so you guys now have enough. Well, you should have plenty to go on from here. All right, in order to solve these things. Now, if you, while you're working, okay, and you have any questions, please let me know. And whatever we don't finish is for homework.